Okay, our next chapter is chapter 6 actually, which is the principal component analysis or PCA. In your textbook, it is in chapter 8, page 430. So, first of all, I will introduce you what is actually the principal component analysis and what is the objective of the component analysis. Okay, so actually the component analysis ataupun dipanggil principal component explaining the variance covariance structure of a set of variables through a few linear combination of these variables. So as you know before this, from the linear combination kan you tahu we have several linear combination and we can use we can find the variance covariance metric for the linear combination. Okay, so untuk principal components, we will explain the variance covariance structure of the set of variables through a few linear combination of these variables. Okay. Okay, linear combination tak sama dengan variables kan? You have several linear combination with several variables. Okay, the objective of the principal component ada dua, which is the data reduction dan juga interpretation. Okay, so actually, principal component, we use the principal component to reduce ataupun to summarize a large set of variable. Okay, we have a large set of variable. We can reduce ataupun summarize the large set of the variable using the smaller set of factor ataupun component by looking for groups among intercorrelation of a set of variable. Okay, we have a large set of variable, then kita akan gunakan factor ataupun component, dipanggil principal component. How we can do this? By looking for the intercorrelation of a set of variable. So you akan tengok nanti kita akan we need to calculate the correlation between the principal component dan juga variables. So we can see which variables are more important to which of the principal component. Okay, and then the assumption of the principal component is it does not need the normality assumption in general. Okay, we do not need the assumption of the multivariate normal assumption. Saya tak perlu normal assumption untuk kita conduct the principal component analysis. Okay, so remember our intention untuk gunakan principal component ni adalah to reduce of this large set of variable using the smaller set of the component by looking at the intercorrelation between the variables. Okay, so let's say we have a random vector. Okay, bool of x kat situ. Okay, x transpose. So we have the variables x1 until xp. Okay, and then we have the covariance matrix of big sigma. Okay, you know how to find the covariance matrix, but in this case biasanya dia akan bagilah the covariance matrix untuk you determine the principal component. And then we also have the linear combination, which is yi equal to ai transpose xi. Kalau you tengok textbook page 431, the linear combination dia tunjuk dalam equation 8.1 page 431. Okay, so this linear combination actually that you have learned before this ataupun you have familiar before this in the previous chapter. Okay, so if we have two linear combination, it will be y1 and y2. Okay, bila you multiply matrix A I dengan X tadi, you akan dapat linear combination dalam bentuk function macam tu. Okay, itu dipanggil linear combination. You can refer page 431. Okay, so we will have yi ni sehingga P. Okay, which is the linear combination of y1 until yp. Okay, and then we also can find the variance of the linear combination using the formula of this, and the covariance using this formula. Okay, this formula actually you have learned before this in the previous chapter, but for this topic nanti I akan tunjuk the theorem how we can find the principal component. Okay, actually using the concept yang sama, gunakan variance covariance matrix. Okay, let's see the first theorem. Okay, let's say we have the covariance matrix big sigma of a random vector of x. Okay, we have random vector of x, so it can be ada x1, x2 until xp. Okay, we have the variance covariance matrix big sigma with the eigenvalue and eigenvector of lambda I and ei. Okay, remember before this, what is the eigenvalue, what is the eigenvector that you have learned in chapter 2. You know how to find the eigenvalue and eigenvectors. Okay, notation untuk eigenvalue adalah lambda I. Okay, maksudnya lambda 1 adalah if we have matrix A ataupun variance covariance matrix, okay, using the formula of apa formula dia, A minus lambda I absolute value equal to 0 kan, you will get the value of lambda I. So every value of eigenvalue will have the pairing of the eigenvectors dalam bentuk vectors. Okay, ei ni adalah notation untuk normalize eigenvector. Okay, eigenvector x kan, normalized eigenvector will be e. Okay, the formula untuk dapatkan eigenvector pun you have learned before this actually. Okay, so when a covariance matrix is big sigma, and then all the eigenvalue is positive, so we can find the principal component by yi equal to ei transpose multiply x. Okay, so let's say kalau kita nak cari the first principal component, so it will be y1 equal to normalized eigenvector e1 transpose multiply x. Okay, so the ei tu adalah normalized eigenvector. So you akan so sebenarnya let's see, okay, here okay, so before this okay, tak kejap lagi lah I tunjuk yang ni bila I tunjuk example. Okay, okay, so untuk dapatkan the principal component, it is yi equal to ei transpose multiply x. Ei adalah vector. Okay, adalah vector transpose, so dia punya vector sebenarnya dia akan jadi p by 1 sebenarnya kan. So kalau e transpose, it will be 1 by p. Okay, multiply matrix vector x, vector x p by 1. So you akan dapat the set of the linear combination. So y1 will be a linear combination. The first principal component will be the linear combination. Because of that lah kita katakan the principal component ni dalam terms of linear combination. Okay, y2 pula you akan dapat y2 equal to e2 transpose multiply x. X tu akan jadi x1, x2, x3, depends lah how many variable that involved. Okay, so sehinggalah yi ataupun yp. Okay, and then the theorem juga you need to know that to find the variance of y, tadi kita ada matrix of sigma ni, variance covariance matrix big sigma adalah belong to random vector x. Okay, kalau you punya variable ada ada 3, so you punya variance covariance matrix will be 3 by 3. Betul tak? Okay, so sekarang ni Y adalah principal component dalam bentuk linear combination. So we can find the variance of the linear combination YI ataupun the variance of the principal component YI by you multiply the variance covariance vector variance of yi equal to eigenvector, normalized eigenvector I transpose multiply variance covariance matrix X, okay, multiply EI, okay, and it is actually equal to lambda I. Kalau we have two principal components, so you akan ada Y1 dengan Y2. So Y1 dengan Y2 ni, variance of Y1 will be actually the value of the first lambda 1 ataupun first of eigen value. Variance of Y2, which is the variance for the second principal component, will be the lambda 2. Okay. Let's say you don't have the value of lambda I. Okay, you can find using this formula. Okay, so nanti kita tengoklah example sekejap lagi. Okay, yang kedua, the theorem that you need to know that the covariance between the principal components is always 0. How to prove this? Using this formula. Okay, EI maksudnya variance eigenvector that belong to first principal component. Let's say kalau kita nak cari covariance of Y1 and Y2, so maksudnya you need to multiply the vector of eigenvector for the first principal component, multiply variance covariance matrix of X, multiply tadi ada transpose first eigenvector for the first principal component. This one EK adalah tadi kat sini Y2, kat sini Y2, so kat sini will be E2, means that the eigenvector for the second principal component. Okay, let's see the example. Okay, let's say we have X transpose is X1, X2 and X3. So we have 3 independent variables ataupun we have 3 variables X1 and X2 and X3, and then given the variance covariance matrix of X 3 by 3. Okay, so from the variance covariance matrix we can find the pair of eigenvalue and eigenvector. Here is given. Okay, how to find this? Okay, remember from chapter 2, the formula to get the eigenvalue is sebelum ni it will be absolute value of A minus lambda I equal to 0. So now we just replace A tadi dengan variance covariance matrix. Okay. Alright, so eigenvalue you akan dapat beberapa lah eigenvalue. Kalau you punya variable ada 3 tadi, X1, X2, X3, so eigenvalue you akan dapat 3, lambda 1, lambda 2 and lambda 3. And then for each of the eigenvalue, each of lambda tadi, you can find its pair of eigenvector. How to find that? Using this, big sigma multiply X equal to lambda multiply X. Okay, you know how to find these eigenvectors. Kalau lupa, tengok balik chapter 2. Okay, so yang kita nak cari the formula to find the principal components tadi, kita nak normalize eigenvector kan EI. So this is the formula. The eigenvector divide dengan square root of X transpose X. X ni ke atas ni adalah eigenvector yang you dapat when you use this formula. Okay, so you akan ada if you have 3 lambda, you akan ada 3 jugalah normalized eigenvector. Okay. Alright. So, let's say here is given the pair of the lambda dan juga E, the pair of eigenvalue and normalized eigenvector. Okay. Biasanya untuk eigenvalue and eigenvector kan you buat untuk 2 by 2, betul tak? Okay, 2 by 2. Kalau 3 by 3 usually dia akan bagilah. Okay, 2 by 2 it's easy for you to find the eigenvalues and eigenvector untuk 2 by 2 matrix. Okay, so let's say here we have all the value of lambda dan juga eigenvectors for each of this lambda. Okay, so now we see how to find the principal component. So principal component pun kita akan ada 3 lah, y1, y2 and y3, because of we have tadi 3 by 3 ataupun we have 3 variables. Okay, so this is the formula macam tadi, yi equal to ei transpose multiply x tadi, betul tak? So kita gunakan konsep yang sama. Okay, ei transpose, ini value ei transpose. Okay, ianya adalah 1 by 3. Okay, so 1 by 3 here multiply by 3 by 1, so you akan dapat a linear combination, which is the first principle. The second principal component pun sama. This is the normalized eigenvector untuk the second lambda. So multiply dengan x, x1, x2, x3. So last kali you akan dapat x3 saja sebab yang lain-lain ni 0 kat depan tu kan. So sama juga dengan y3. You need to multiply the eigenvector transpose, multiply the vector of x. Then you will get the principal components. So we have these 3 principal components. Okay. This is the yang ni yang tadi. Kita nak tengok macam mana nak dapatkan principal component using this theorem. Okay, let's see pula macam mana the theorem mengatakan yang nak prove that yang ni. Variance of yi equal to lambda I. Okay, let's see here. Variance of y1. Okay, variance of y1, formulanya tadi adalah okay, E1 transpose multiply big sigma multiply E1. Okay, we have the normalized eigenvectors tadi. We have the variance covariance matrix. Okay, multiply these 3, you akan dapat satu value. Sebab 1 by 3, 3 by 3, 3 by 1, you akan dapat satu value. Satu value tu ialah dipanggil variance of first principal component. So you akan dapat 5.83. 5.83, it is equal with the first of eigenvalue. Okay, the variance of the principal component adalah equal with the eigenvalue. Okay, so kalau you tengok kat sini dia, ataupun dalam textbook you kat example 8.1, the way it's find the variance of y1 is like this. Boleh juga, okay, sama ada you gunakan this matrix as a matrix of eigenvectors tadi, multiply dengan variance covariance matrix, ataupun boleh gunakan that formula, okay, which is this one. Let's say y1 equal to ax1 plus bx2 tadi kan. So the variance of y1 will be, bila you variance kan all of this linear combination kan, so dia punya perkali kat depan ni akan jadi a square. Okay, multiply variance of x1 plus b square multiply variance of x2, then plus 2ab multiply covariance of x1, x2. So macam mana dapatkan variance of x1, macam mana dapatkan variance of x2, macam mana dapatkan variance covariance of x1 and x2 is from the value from the matrix covariance matrix of big sigma. Okay, so you boleh tengok nanti. Okay, dalam your textbook example 8.1 ni ada dekat page belakang sikit. 434. Okay, boleh check. Okay, satu lagi tadi kita punya theorem tadi, dalam theorem 8.1 dikatakan covariance of the two linear the principal components is 0. So you try to apply, you cari E. Let's say nak cari covariance between y1 and y2, so it will be E1 transpose multiply variance covariance matrix multiply E2, you akan dapat 0. So we can remember ataupun we can say that the covariance between the two principal components is 0. So kalau ditanya what is the covariance between y1 and y3 contohnya, if y1, y2 and y3 adalah principal components from the variance covariance matrix given, so you can say that the covariance between y1 and y2, covariance between y1 and y3, or covariance between y2 and y3 is equal to 0. Okay, alright. Okay, let's see the next theorem, result 8.2. Okay, your textbook, page 432. Okay, so this theorem saying that, okay, we know that this is the ith principal component tadi from the previous theorem, result 8.1. So from that we also can know that the summation of variance of x, macam mana dapatkan variance of x ni? Daripada variance covariance matrix big sigma tu. Okay, lambda 11, sigma 11, sigma 22, ini semua adalah daripada main diagonal from your big sigma matrix. Okay, equal to, sebenarnya total of the variance of x equal to total of the variance of y. Okay, so that bila you ada variance covariance matrix of x, you also can find the summation of variance of y sebenarnya, and it is also equal with the summation of all the lambda ataupun eigen value. Okay, that is the second theorem. Another one, okay, if we want to find the proportion of the total variance due to the kth principal component, kita nak tahu whether how many percent the first principal component or the second principal component will contribute. Okay, we contribute how many percent, we can use this formula. Okay, boleh tengok dekat page 433, equation 87. Okay, this is the formula to find the proportion of the total population variance due to the kth principal component. Okay, we are using the value of eigen value. Let's say kita nak tahu how many percent first principal component give contribution. So kita buat kat sini lambda 1 divide dengan summation of lambda. If you want to know how many proportion of the total variation due to the second principal component, so here will be lambda 2 divide dengan summation of lambda. Okay, so kalau you tengok dekat page 433, it's saying that if most, which is 80 to 90% of the total population variance, daripada sinilah yang you dapat ni, for large P can be attributed to the first 1, 2 or 3 component, then this component can replace the original P variables without much loss of information. So bila you punya proportion you tinggi, bila you calculate kan, we can say that this component yang you check tadi sama ada first principal component ke, second ke, third ke, these components can be replaced the original P variables. So untuk kita nak explain, kita boleh gunakan this principal component untuk replace the variables of x1 or x2 or x3. Let's see the example from example 8.1, example yang sama tadi dekat page 435. Okay kan, from this example tadi we have all this information about the lambda. We have all this lambda. Okay, so okay, so tadi kita nak check tadi betul tak summation of variance of xi equal to summation of variance of yi. Okay, bila you total up all the variance of x, which is you total up all the main diagonal here, kan, you akan dapat 8. Betul tak? Itu adalah total of variance of x. Total of variance of y pula adalah total of lambda, which is you add all this lambda ataupun eigen value, you akan dapat jawapan yang sama 8. So terbuktilah kita punya theorem tadilah. We can say that the variance summation of variance of xi equal to summation of the variance of yi. Maksudnya summation total of variance of variables equal to total of the variance of principal component. Okay, let's see when we find the proportion of the total population variance due to the kth principal component. Let's say kat sini kita cari total proportion for the first principal component, lambda 1 equal to summation of lambda. So lambda 1 will be 5.83 divide dengan altogether is 8, so you akan dapat 0.73. Okay, 0.73 bila kita hanya gunakan one principal component. Okay, bila buat pula lambda 1 plus lambda 2, maksudnya kita cari the variance of the proportion of the total population variance due to first principal component and the second principal component, so you will get 0.98. Okay, so maksudnya kat sini bila we have only one we using the first principal component, you akan dapat 0.73. Bila kedua-dua principal component is used, the proportion will be 0.98. So what can we conclude from here? We can say that the components of y1 and y2, okay, the principal component of y1 and y2, which is y1 and y2, can replace the original three variables x1, x2 and x3 with little loss of information. This sentence ada dekat page 435 ke atas sekali. Kenapa? Sebab bila kita cari the proportion of the total variance tadi, population variance, you akan dapat 0.98, which is besar lah kan, 80 to 90%. So kita katakan the principal components can replace, principal component of y1 and y2 can replace the original three variables. Kalau principal component y1 saja tak cukup sebab 0.73 saja. Okay, principal components y1 and y2 can replace the original three variables. How about y3? Kalau y3 saja, cuba kira kalau y3 saja 0.17 divide dengan 8. Sikit saja kan? So kita boleh katakan y3 principal component of y3 tak membantulah. So y1 and y2 saja could replace the original three variables. So daripada 3 variable kita boleh reduce ataupun minimize kepada 2 principal component. Faham tak? Okay? Alright. Okay, the next one adalah the results ataupun the theorem when we find the correlation coefficient. This theorem, we can use this theorem untuk nak tahu which variable contribute to the which principal component. Okay, so this is our principal component formula from the covariance matrix big sigma. Okay, the formula will be apa ni panggil rho of yi. Y adalah refer kepada principal components, x adalah refer kepada variables. Okay, so eik, okay, which is the element from the eigenvectors, normalized eigenvectors. Nanti kita tengok dia punya example. Multiply square root of the lambda I. Okay, lambda ni bilang kepada principal components, divide dengan square root of sigma ataupun standard deviation of kk belong to the variables. Let's say you want to find the correlation between first principal component and first variables. First principal component and first variable, so it will be rho y1 x1. So E11 ni, so E kat sini akan jadi E11, first principal component, first variable. Kat sini will be square root of lambda 1, belong to the first principal component, divide dengan standard deviation of first variable 1 tadi kan. So you tahu macam mana nak cari lambda 1, you tahu macam mana nak dapatkan value daripada standard deviation of the variables. What about this one? Normalize eigenvector I1k. Okay, let's see here. Okay, the first element kat sini adalah I1. Maksudnya let's say kat sini E1 transpose. E1 transpose maksudnya adalah eigenvector for the first principal component. Kan? First eigenvector for the first principal component. So you akan ada kat sini EI1, EI2. Maksudnya kat sini adalah EI1 adalah E belong to I principal component for first variable. EI2 eigenvector belong to the first I principal component for second variable. Okay, that is the way how you find the value of EIK. Okay, so tengok example, guna example yang sama tadi. Let's say kita nak cari untuk the first principal component, kita nak cari which variables are most important to the first, second and third principal component. Let's say start dengan first principal component y1, kita ada x1 dan kita ada x2. Kenapa tak cari untuk x3? Sebab kita tengok kat sini 0 dia punya variance. Okay, dia punya eigenvector is 0. Eigenvector is 0. So sebab tu lah kita hanya boleh cari the correlation between first principal component and first variable, first principal component and second variable. So using the formula, so E11 kat sini 0.383 we get from here. E11 kat sini E12 kat sini. Okay, di sini lambda 1 belong to first principal component. Kat sini square root of 1 sebab standard deviation untuk first variables. Kat sini square root of 5 because of the variance for the second variables. Okay, so lastly you akan dapat 0.925 for the first variable and negative 0.998 for the second variable. That is the correlation. So from here we can say that these two value in absolute value, x2 kan, this value 0.998 lagi besar kan, so we can say that x2 will contribute most to the first principal component since the correlation of y1 x2 is more than the correlation between y1 and x1. Okay, so using the correlation value ni, we can find which variable contributes the most to the principal component. Okay, yang kedua, principal component yang kedua. Okay, untuk first variable and second variable is 0 because of this kan, sini 0 dia punya eigenvalue, eigenvectors. So untuk second the third variable, the value is 1. Okay, so maksudnya memanglah the third variable sahaja yang contribute untuk principal component yang kedua. Okay, tadi untuk principal component yang pertama tadi kita ada dua variable x1 and x2, so we want to know which variable most contributes to the first principal component. But untuk the second principal component, kita hanya ada satu variable saja, x3 saja dalam principal component tersebut. So memang x3 je lah yang contribute the most to the principal component. Okay, alright. Okay, another way to find the principal component is by obtaining from the standardized variables. Okay, so as you know, when we want to standardize the variables should be minus its mean and divide its standard deviation. Okay, caranya sama like before this. You need to find the eigenvalues, eigenvectors, which is your the way how to find the principal component is yi equal to the transpose of the eigenvectors multiply by x, right, the variable. But now x tadi tu kita gantikan, we replace x with z, which is dipanggil standardized variable. So x tadi bila you gantikan dengan z, so this is how we transform x from z. You should minus the variable with its mean and divide its standard deviation. Okay, and then z also we can write it as dalam bentuk matrix. In matrix notation also we can write it as v power of negative half, maksudnya kat sini inverse of the square root of matrix V, okay, multiply by matrix of x minus mu. So V, if you can remember, V adalah diagonal matrix of variance. Betul tak? Diagonal matrix of variance. Okay, so because of that, V square root of V kat sini will be the main diagonal semuanya adalah square root of the variance of the variable. Okay, kalau matrix V sahaja, the main diagonal will be the main diagonal here will be the variance, but because of here we want to find the square root of the variance, square root of the V matrix, so all the main diagonals should be square root. Maksudnya all the variance of the variable should be square root, and then all the other element will be 0. Okay, because this is the main diagonal matrix of variance. Okay. Okay, and then the formula to find the covariance of Z, matrix of variance covariance of Z will be like this. Pernah jumpa kan? How to find the covariance matrix, which is you need to find the inverse of the square root of V multiply the big sigma, which is the variance covariance matrix of X, multiply dengan inverse of square root of V matrix. So you akan dapat P by P matrix, okay, which is actually that P by P matrix adalah equal with the correlation matrix rule. Okay, remember from the previous chapter, you know that all the main diagonal for correlation matrix will be 1. And the other element kat sini, row 1, 2, means that row 1, 2 here means that the correlation between first variable and second variable. Okay, so the other element akan ada dia punya nilai correlation between the variables. The main diagonal will be 1. Okay, so let's see how we find the principal component using the standardized variables. Okay, it is equal, the method is equal, cumanya the eigenvalue and eigenvector, we obtain the eigenvalue and eigenvector from the correlation matrix. Before this, we obtain the eigenvalue lambda and eigenvector ataupun normalized eigenvector E using ataupun from the variance covariance matrix big sigma, betul tak? But now we find the lambda and E from correlation matrix. So how to find the correlation matrix? Using this formula ataupun ianya adalah rho. Okay. Okay. So the formulanya untuk dapatkan principal components, I principal components is this one, yi equal to transpose of normalized eigenvector ei multiply by standardized variable z. Before this, z ni adalah x, but now we replace x with z. Okay. So if we want to find the first principal components, it will be y1 equal to transpose of e1 multiply by z. Okay. Z tu akan ada ni lah, z1, z2, z3 kan, when we standardize the variable tadi, we transform from x kepada x minus mu divided by sigma. Okay. And then according to the theorem also, when we are using the rho to find the principal component, we should know that summation of variation atau summation of variance ataupun total of variance of the principal component equal to total of the variance of variable z, which is the standardized variable, equal to p. Okay, p, bila you total up all the variance of y and all the variance of z, you akan dapat nilai p, which is the number of variables. Okay. Another one adalah from the theorem also, we can find the value of rho yi zk, which is we can find the correlation ataupun we can find the which one of the z will contribute most to the y. Betul tak? Okay, this is what I told you just now. When we have the value of big sigma, variance covariance matrix, we can find the value of eigenvalue, which is lambda, using this formula. Okay, untuk dapatkan eigenvalue lambda, we will use this formula. Okay, and then when we have the eigenvalue, so we can find the normalized eigenvector. But if we want to find the principal component obtained from the standardized variables, we will use the value of correlation, the matrix of correlation to find the value of lambda, which is the eigen value. Okay, so this is the formula. Just replace big sigma dengan correlation matrix rho. Okay, so the other steps is equal. Okay, this one adalah formula to get the principal component when we have x variables and the matrix of big sigma, and we will use this formula to find the principal component obtained from the standardized variables, and we also have the value of rho. Okay, the matrix of rho. And the Z is this one, like I explained to you just now. We transform from X to Z, which is we need to minus the variable with its mean and its standard deviation. Okay. Alright, another one from the theorem, also we can find the proportion of the total variance due to the kth principal component. Before this, if we are using the matrix of sigma, the formula is lambda k divided dengan summation of lambda, kan? So actually this equal with this, the formula for when we are obtain the principal component using the standardized variable. It is okay, let's say we want to find the first principal component, how many the proportion of the total variance to the first principal component. It will be lambda 1 divide dengan summation of lambda ataupun equal to P pun boleh. Okay, sama je. Bila you total up all the lambda, you akan dapat P sebenarnya. Okay, sama juga dengan total of the variance lah sebenarnya. Okay, let's see the example. Okay, example ni dalam your textbook, page 437, example 8.2. Okay, let's say, okay, kat sini dia tunjuk perbezaan, okay, the difference between when we are using the big sigma and when we are using the matrix of correlation rho. Okay. So we have these two value. So actually, from the if we have the big sigma, we can find the matrix of V. Betul tak? Okay, let's see one by one. Okay, let's say we want to find the eigenvalue. We want to find the eigenvalue using the big sigma. Okay, so we will use the formula of this one. Okay. So, kat sini dia dapatlah these two eigen value and its pairing of the normalized eigen vector. Okay. When we are using the correlation matrix, we will use this formula to find the eigen value. So, nanti you try buat, you will get this answer. Okay. The value of lambda is different. So means that the standardized variable ni will give ataupun will affect the value of lambda dan eigen vector, normalized eigen vector. Okay. Let's see. Let's see pula what is the, kat sini dia tunjuk dulu how you get the value of variation, right? Value of variation, proportion of population variance. How many percent or how many proportion of the principal component will contribute when we are explaining the variables. Okay. So this is the principal component. Let's say this one, macam mana dia dapat 0.992 dekat sini. Dalam your textbook actually ada. Okay. Which is lambda 1 divide dengan lambda 1 plus lambda 2. You akan dapat 0.992. So maksudnya kat sini when we are using only the first principal component, the total variation is high, right? Because of it is 99.2%. When we are only using the first principal component, so it is enough. We can use the first principal components to explain ataupun to replace the variables x1 and x2. Okay, let's say kat sini pula when we are using rho, okay, it will be lambda 1 divided by p tadi kan, so it will be 0.7. Also we can say that for the first principal components is also enough to replace the value of ataupun to replace the first variable and the second variables. Okay, that is the way how we interpret the proportion. So lagi satu saya nak cerita pasal proportion ni. Sebelum ni I lupa nak bagi tahu So the proportion of the standard or not of the population variance adalah actually to determine the degree of a variation in the data contributed by each of the PC. So kita nak tengok berapa banyak principal component variation in the data contribute by each of the principal components. So let's say tadi kalau kita nak tengok first principal component berapa persen dia contribute, kita akan buat lambda 1. Kalau you nak check untuk second principal component, you akan buat lambda 2. Okay, it is to determine the degree of variation in the data contributed by each PC. And also we can make the decision whether which principal component ataupun how many principal component that can be used to replace the variables, okay, x. Okay, and then you should know also the number of PC ataupun the number of principal component to be used based on the cumulative percentage value of at least 70%. So kalau macam ni kan, kita test untuk first principal component dulu. So the value is 0.992. So kita katakan only first principal component je lah diperlukan to replace ataupun it can be replace the variables. Let's say kalau you test untuk lambda 1 ataupun the first principal component, you akan dapat let's say 0.3 saja. So the first principal component alone cannot be give contribution to replace the other variables. Okay, the all the variables. So maybe we can try pula lambda 1 plus lambda 2. Tapi kalau kat sini kalau in case of ada dua je principal components, kalau you buat lambda 1 plus lambda 2, you akan dapat 1 lah. Okay, let's say kalau you ada 3 kan, let's say you ada 3 principal components. Okay, so let's say you have 3 principal components. First principal components you test is 0.3. So you test another one first principal component and second principal component. So it will be lambda 1 plus lambda 2 divide dengan all the lambda. So kalau the value of the variation is more than 70 ataupun 70 and above, so it is enough for us to say that the first principal component and the second principal component are enough to explain ataupun to replace all the variables that we have. Okay, I hope you can understand that in terms of the proportion, the function, okay, of the proportion. Okay. Okay, let's say I nak explain about this. This is y1, this is y2, which is the principal component using this formula. Using this formula tadi. Okay, this one, right? Using this formula and this formula. We will use this formula when we have the big sigma. We will use this formula when we have row, matrix row. Okay. Okay, so if we are using the matrix of big sigma, so these two value yang you akan dapat principal component. Okay, all this value kat sini adalah daripada eigen vector tadi, normalized eigen vector. Okay, when we are using the value of from the row matrix, this is that you get these two principal component, dan Z tadi gantikan dengan kat sini because of Y1, so it will be X1 minus mu1 divide dengan di sini value of Z kat sini. Okay, we replace with X minus mu divided by sigma. So in this case for Y1 X1 minus mu1 divide dengan square root of sigma 11 dekat sini. So how we get the sigma 11? We can get from the big sigma matrix kat situ 1. Okay, kat sini pula Z2 kat sini kita gantikan dengan X2 minus mu2 divide dengan should be divide dengan this one, square root of 100 will be 10 sepatutnya kat situ. Dia tertinggal kat situ, bahagi dengan 10. Okay, dah betul. Sebab dah betul. Sebab value tadi kat sini sepatutnya value dia adalah 0.7 kan. Dia dah bagi dengan 10, so dia akan dapat 0.0707. So it seems goes with the second principal component. Untuk Z1 you replace dengan X1 minus mu1 divide by 1. Okay, untuk Z2 you replace dengan X2 minus mu2 divide dengan 10, which is the square root of 100. Okay, so that is the way how you find the principal component, and there's a difference between the principal components when we are using the big sigma and the row matrix. Okay, the last one is when we want to find the correlation between principal component and variable Z. Okay, standardized variable Z. So as you know, we find the correlation. Okay, we find the correlation because we want to know which variables are contribute most to the corresponding principal component. So let's say kat sini row Y1 Z1, so means that according to the formula it will be E11 multiply square root of lambda 1. So square root of lambda 1, okay, lambda 1 adalah, okay, lambda 1 tadi adalah 1 over 4. So multiply dengan E11, which is the E11 adalah element dalam normalized eigen vector. So 0.707 multiply dengan square root of 1.4, you will get 0.837. Ini di antara correlation between first principal component and the first variable. This one pula first principal component dengan second variables. So E12, okay, so E12 will be this value, the same value yang you dapat. Okay, multiply dengan square root of 1.4 juga, you akan dapat the same answer kat sini. Okay, so means that dua-duanya Z1 and Z2 will give the same contribution in explaining ataupun for in the first principal component. Okay, that's all actually. And then another one that I want to stress ataupun the knowledge for you, for your knowledge, we will use the principal component obtained from the row tadi is more appropriate when the measurement scale of the variables are different. Okay, because of row will manage the difference in the data scales. So bila nak guna row, okay, kita akan gunakan row if if the measurement untuk X is different. Okay, kalau first variable level measurementnya adalah kilogram, second variable dalam cm. So it is appropriate to use the row ataupun the correlation matrix untuk to find the principal component. But in exam, kalau dia bagi you value of big sigma matrix or row matrix, so you just gunakanlah which information that gives you, tak kisahlah dia punya measurement tu. Okay, but actually it is the way. Okay, sorry tadi tu yang tak ada bateri, sebabnya saya dah nak habis ni. Kalau saya buat balik lama pula. Okay, thank you.